Hey guys, so today we're going to be doing compound inequalities. So what that means is you're going to have more than one inequality to solve for. So if we look at example 1 is I have negative 3x plus 6 greater than 20, or 1/3 x plus 4, which is greater than 10. So what this or means, and I'm actually going to box it, is this means that these are two separate problems. So I'm going to solve them each individually. They're both going to have a different answer, and that's okay. So I'm going to start with this left one. So negative 3 parenthesis x plus 6 parenthesis greater than 20. And just like in that last video, I'm going to draw a line down the inequality. And I'm just going to solve for it like I normally would. So this negative 3, I'm going to distribute to the x and 6. You guys can't see the negative. So negative 3 times x is negative 3x. Negative 3 times 6 is negative 18. You have greater than 20. Now I want to solve for x, so I'm going to add that 18 because it's minus 18, so you're going to use the opposite operation. So I'm going to add 18 to both sides. Negative 18 and 18 cancel out. Negative 3x is greater than 20 plus 18 is 38. And then I'm going to divide by a negative 3 because I want to get x by itself. And remember, when you divide by a negative, you're going to flip that sign. So I'm going to get x is less than 38, negative 38 over 3. And I'm going to leave it improper. I know we went over this in a past video, but in this class, we're going to keep things improper. It's going to help you when you get to further math. So just leave it like that. And that problem's actually solved. So that part is fine. This is an or statement, so I was going to say x can equal this or whatever we get here. So let's look at this one, and I'm going to rewrite it. So I have 1/3 x plus 4 is greater than 10. And I'm going to draw a line down the inequality, and then I'm going to solve it just like I would for a typical equation. So I know that there's a fraction. I can't get rid of that first. I need to get rid of that 4 first. And the opposite operation of addition is subtraction. So I'm going to minus 4 on both sides. So I'm going to, remember, these cancel out. They go bye-bye. So I'm going to have 1/3 x is greater than 10 minus 4 is 6. Now here's that tricky part, because I know you guys don't like fractions. So to undo a fraction is I'm going to multiply, and I'm going to multiply by 3 over 1. And the reason for that is the 1s are going to cancel and the 3s are going to cancel. So I'm left with x is greater than, and remember it was positive, so I don't need to change the sign. And 6 times 3 is 18. 18 over 1 is just 18. Okay, so here's another answer. But I'm actually going to write it out. So I'm going to say, sorry, I'm trying not to show you the next example. X is less than negative 38 over 3, or x is greater than 18. And that's my answer. And again, I have two different answers because I have two separate problems here because it's an or problem. Or. Now, in my next example, we have an and problem, so it's combined together. So I have 1/2 is less than 2x minus 9 over 2, which is less than or equal to 3. Now this is an and problem, and what I'm going to do is I'm going to divide this up. So I'm going to draw a line down this inequality and this inequality, so I can see that there are multiple sides here. Whatever I do to one side, I have to do to the other. So I'm looking to solve for x in the middle. That's my goal, is to have x. And I have a fraction, and I hate fractions, so we're going to get rid of it by multiplying by 2. Okay, multiplying by 2. Here, in the middle, these cancel out, so I'm left with 2x minus 9. And I'm going to rewrite these signs because they're not going to change. Now on this side, 2 times 1/2, well, these 2's cancel out, and I'm just left with 1. So that's actually really nice because that fraction went away. We got rid of this one and this one. And then 3 times 2 is 6. Now if I look in that middle, I have 2x minus 9. I want to get rid of that 9. And the opposite operation of subtraction is addition. So I'm going to add 9 to all of the signs. Here, negative 9 plus 9, bye-bye. So I'm left with 2x. And I'm going to rewrite those signs. 9 plus 1, 10. Not bad. 6 plus 9 is 15. Okay, don't stress. You can get a fraction for an answer. I know that's starting to come up. Now my last step, remember this 2x, they're really being multiplied. So the undue multiplication is division. So I'm going to divide by 2, divide by 2, divide by 2. The 2's here cancel. And I'm just left with x, which was my main goal. And the signs don't change because I divided by a positive. 10 divided by 2, 5. 15 divided by 2. That's, some decimal, but I'm going to keep it as an improper fraction because I can't reduce it. So this right here is my answer. So let's recap the video. If it's an OR problem, it'll state it. Like here it said OR, so that means x can equal this, or x can equal that. When it's an AND problem, it just means the solution is in the middle, okay? That's like when we did our first graphing inequality. So the answer is going to be somewhere in between 5 and 15 halves. So make sure we pay attention. If it's combined like this, then it's an AND. If you see the word OR, it's an OR problem. So keep an eye out for that.